attaching another one on the end. The concatenation for the C++ string only operates on strings and characters, though. Whereas in Java, right, there's this kind of automatic mechanism where things like doubles and integers are converted to string and added into the concatenation. That does not happen in C++. So concatenation is just for strings and characters. If you have something that's in numeric form and you want to add it into a string, you'll have to first convert it to a string. I'll show you a routine that does that a little bit later. Okay. Yeah.
Slides available.
Sure. Easy enough to do. I'd be happy to do that. There's most of the things that I'm talking about actually are in the handout 4 as well as repeated in handout 10 and in the readers. So you got like a million places you can look for information on strings, but no harm in having one more. Most of the heavy lifting on the strings is done via these member functions. So these are part of the string class, and so these are operations that apply to string receiver objects. So they're not free functions. You can't call them outside of a usage where you're saying, on some receiver string, apply this function using these arguments. So, for example, the length member function is applied to a string. Just to note here, the word member function is vocabulary-wise the same thing as method, that Java programmers tend to call the functions that are defined as part of a class methods. C++ programmers tend to call them member functions. They really mean the same thing, but I do try to use the word member function because we are a C++ class, and that is kind of the convention. But I'll probably end up using both accidentally without even noticing it, but hopefully it won't cause you too much grief there. So the member function here is saying stir.function args is saying apply the function, send the message function to this particular string with these arguments and then get its answer back or have that operation happen. So I can ask a string for its length. Turns an integer, tells you the number of characters. I can ask a string to look for a particular character or a particular string sequence, substring, within the characters that string maintains right now. It will return the index of the first occurrence found, scanning from left to right, or a string : npos. It's a little bit of a funny return value, but it is the return value that says I didn't find it. And so string : npos is kind of an integer value that is distinct from any other valid index within the string itself to tell you it didn't find it. Both of these have a default argument on them. We talked a little bit about that last time. And if I do not specify that second argument when I'm making a find call, then it will assume that you want to start looking from the beginning, position 0. If I do specify it, then it will start from that position and scan from there to the end of the string. So it's a way of targeting the place you're looking for it a little more precisely than just starting from the beginning and going to the end. C++ does allow what's called overloading. In this case, the function find that finds a char and the function find that finds a string both have the same name. And so that name can be used for multiple purposes as long as there's a sequence of arguments that distinguishes them so that when I make a call to find, it knows whether I meant the first version or the second version by virtue of whether the first argument is a character or the first argument is a string. And that can be extended to other types. This is typically used when you have an operation that really has the same behavior, but just some slightly different sequence of arguments is required to invoke it. It is not something you'd want to use a lot to make a bunch of similarly named functions that don't have similar operations. So it just allows for a convenience when there's 2 or 3 variations of the same theme. They might all come under the same name by virtue of overloading. And then these are ones that, well, maybe I'll do substring first, and then I'll mention these are all kind of together. Substring is something that, given a receiver string and a position and a length, will extract a new substring out of the middle of the string that was received. So if I say to the hello string, starting from position 0, take 2 characters, I get the string he. It copies them. It's distinct from the original. And so all it did was kind of get its initial sequence by copying characters from there. But if I go on to change the hello string into jello, right, that he string stays he. So they're not attached in any long-term way. Then insert, replace, and erase are all of the family of something what I call modifiers or mutators that change the receiver string. You can send these messages to a string to cause new text to get added into the string, text to be removed, or text to be kind of deleted and replaced with something else. So inserting, so someone asks, well, how can I put new characters in the middle? Well, I put the position where I'd like him to go. If I say position 0 and I say put the string, I in there, then it would bump everything down and put I in the front and replace it. So if it was hello, it would be I said hello. Let's say I inserted the string I said. The replace, right, at a position removes length character starting at that position and then replaces it with that character. So a way to kind of take a chunk out and put something else in instead. And then erase, which just does a straight remove. Add a position and a particular len, take this number of characters and throw them away, deleting them from the string, making it shorter. So all of these change the receiver string. When you say stir.insert, stir.replace, stir.erase, that after that call, stir now actually has new contents based on what you've asked it to do about changing and mutating its context. So here's something I should tell you a little bit about C++ string relative to the Java string, is that C++ being kind of an industrial strength language that's targeted at professional programmers does not make any guarantees to you about what happens if you misuse these calls. So if you give it a position that isn't valid for the string, or a length that isn't valid for the string, that there is no contract in the C++ libraries that said, well, this is what will definitely happen. It doesn't say, oh, it's definitely going to throw an exception or throw some sort of error. It doesn't say, well, it's just going to truncate at the end. It says that the library is free to do whatever is convenient for it, up to and including just crashing. So it does mean that as the programmer, right, kind of using these calls, it is a little bit more on you to be careful that you're using them correctly, that you're making the numbers are in bounds for the string and things like that in ways that will produce correct results. That it might be that it will produce a nice error message, but no guarantees, and so you wouldn't want to come to depend on that. But you want to just be careful about knowing what the right numbers are. So unlike Java, right, which is very attentive to those sort of things and kind of on your case when you're a little bit out of bounds, in the name of efficiency, it tends to just breeze through that stuff. All right. I'm going to show you, let me just go in and we'll do a little bit of coding in this together, just for fun. Just because I like to sit and show you some things. Just a little practice with some code. So if I were to do something like, let's say, want to count the occurrences of a particular character within a string, right? I could write a loop that looked like this. I could say int, count equals 0 for, and this is a kind of very ubiquitous loop, right, for operating over a collection, in this case the collection being the characters in there, right, from 0 to this length. And if s sub I equals the character I'm looking for, right, we would increment the count and then return it. And so I could put this down here in my code and do a little testing of looking for the character, let's say C, in Chihuahuas. I can't spell. Chihuahua cheese crackers. You guys probably don't read Skippy John Jones, but I do in my house every night. So I know about these things. So let's take a look at that and see if we actually managed to count the number of C's in my list there. So there's 4 apparently. Let's go check and see if that kind of comes out. Chihuahuas, cheese, crackers. Oh, looks good. Okay, so we did a little bit of counting, and we're feeling okay about that part. And then let me do something where, for example, I want to remove all the occurrences from that. And I'm gonna write this 2 different ways just to highlight a little bit about how things work. So I'm gonna design a remove occurrences that, given a character in a string, will return to you a new string where all the occurrences of CH have been removed. Seems easy enough, right? So it's not going to modify the original string. It's going to actually return a new one. So here's my strategy. And this is often the way to build these things up is I could go through the kind of manipulations of kind of, try to take the characters out in place and figuring out where I'm at. But often the easier way to do this is just to build up the result, right? Decide when to append or concatenate a character from the original string and when to ignore it and go past it. So I can do something like this where it's like, well, if the character I've just seen is not the one that I'm trying to avoid, then I can just add it into the result. And then when I'm done, I have the result. So if I do this and I change this call down to remove occurrences. And so I'm counting on, for example, the fact that result is initialized to the empty string. So you notice I didn't actually say anything there. I could, for example, do this. And that doesn't change anything about it, and you might feel a little better about seeing that explicit initialization, but C++ programmers are very used to seeing uninitialized strings, knowing that that means that they got the default initialization to the empty string. And there, when I didn't find the character I was looking for, right, I append it to the result. I'm going to switch this up just a little bit. And I'm going to change remove occurrences to, instead of making a new string, to actually modify the string that I have. So I'm going to change my code down here to match what's going to happen. I'm going to set it to be this. And then I'm going to call remove occurrences, C of S, and then I'm going to print out S afterwards. So in this case, I don't expect there to be a second string created. I expect us to go in and modify that string in place, kind of truncating some of those characters, taking them out to make this work. Okay. So I could kind of do this thing where I'm kind of walking down the string character by character and then deciding whether to collapse over it. I'm actually going to just change my strategy entirely just so I have a little practice using some of the other routines. And I'm going to end up using the string find. So we'll start with this. I can actually do this. S.find of ch, and if I don't give that second argument, it's going to start from the very beginning and look all the way through and see if it finds it. I'm going to hold that result in a variable, and I'm going to say while found equals the result of calling find, and then I'm going to stick it in. This is a very kind of C++ way of coding, right? Is kind of tightly combining this up, but in this case I have an assignment, right, and a comparison all in the test of the while loop. So I'm making the call to ask the string to find a particular character, storing that result in an integer here so I can use it, and then comparing that result to string npos. So the string npos is a little bit of a funny C++ syntax there, but it is the way to read that is within the string class. So string : says within the string class, kind of scoped within string, there's a particular constant called npos, which is used as the return value in cases like find when it's looking for something. And that npos being part of the class is sort of a way of avoiding it conflicting and interfering with any other usages where you might have variables named npos or similar functionality. It's kind of tied to the string class through the scoping mechanism. So I check and see if it's not string npos, and then if it's not, then I go into the loop here, and I can do an erase of one character at position. So erase takes the position and the count, and it just removes the number of characters I specified from that position, and then it'll come back around. I have passed string by reference coming into here, and that's a very important part of what's happening here because these calls to erase that are modifying string, if I have not passed string by reference, right, they'd be operating on my copy, and I'd go through all the trouble of erasing all the C's in my copy, but when I got back out to the main call, none of those effects would have been permanent. So passing by reference really means that what remove occurrences got was access to the original S, and maybe I should even make these names. I'll call this my string out here so that we don't get any confusion about the two names here. The my string variable in main is really being accessed by remove occurrences without a copy. It's reaching back out into main, and it's really making changes to the my string itself, taking its C and deleting it down. And so let's finish the fix to that. What does it not like about that? Oh, pause. Yeah. What did I call it? I called it found. Yeah, well. Okay. So Wawa's he's and wreckers, right? Still looking good, right? So I achieved the same thing, but to a different effect. And that's one of the things about the string library, right? Is it's so big and it has so many different ways of doing things that often, right? 2 people, or 10 people writing the same task won't even come up with the same solutions. I could have used a replace, right, where I replaced found the one character it found with the empty string, right? I can build it up through concatenation. I can take it down with erase and replace, right? I can insert the other way around. A bunch of things I can do. That in the end will achieve the same effect, but just show that there's a lot of different ways to accomplish the same things because the library is pretty rich and has a wide variety of tools in it. I'm going to make one change to this just to show you how I can make it just slightly more efficient. Now this is kind of silly because strings are typically very short, so it doesn't really matter. But I'm going to do this, and I'm going to use found as my index on subsequent calls. So I can say starting found from 0, do my search from 0, and then found, and then any subsequent calls will pick up where I left off. So the next time around through the loop, right, found is at the place where I found a previous occurrence of that character, and it says, okay, starting from that position now, look forward and see if you see any more from here to the end. And so for a very long string, right, this ends up actually doing a lot less work, where it doesn't start all the way back at the beginning each time. It just picks up where the previous occurrence was found and goes from there to the end. So small change, but no big deal. Hey.
Can you explain again string : and
Yeah.